Welcome fellow learners. You're watching a series of LangGraph tutorials. In this video, we'll build a basic ReAct agent using LangGraph, and in future videos, we'll keep adding more advanced capabilities to help you master LangGraph. So in this particular video, we'll begin by creating a graph that uses LangGraph's core features like nodes, edges, and state. Then we will integrate it with an external tool to fetch the data based on the user's query. And finally, we will explore how the agent's reasoning and actions are visualized inside LangSmith and how we can trace each step of the process using LangSmith. And at the end of the video, we'll also see LangGraph's pre-built component for ReAct agent, which makes it more simpler and easy to implement. So now the question comes up, how do ReAct agents work? The ReAct framework takes inspiration from how humans think out loud, like planning and solving problems step by step. So instead of following fixed rules, ReAct agent uses the LLM's reasoning to adapt based on the new information or earlier results. They follow a reason, act, observe loop, repeating it until the query is solved. So if you see in the diagram, once the user's query is provided, the LLM first analyzes the problem and determines the next best step. So this is the reason phase. And then agent executes that step, often by calling a tool. So that is the act step. And in the observe phase, the LLM reviews the tool's output and it will try to see if it needs to again reason it out or it can provide the output directly. So this reason, act, observe cycle continues until the agent produces the final response. So let's take an example. Let's see. We are having a ReAct agent which is having a weather tool. So now if a user ask a question like what is the current weather of Mumbai. So what it will do, it will first go into the reason step or reason phase and it will use LLM which reason it out and finds out what the user is asking for. And it will see the user is asking for what is the current weather of Mumbai. Then it will find out does it have any tool which can respond to the user's query to find out the weather of the Mumbai. So it will see it has a weather tool which is having a weather API and which can fetch the current weather of the Mumbai. So what it will do, it will extract the required information from that user's query like Mumbai and weather, and it will pass that parameter of Mumbai to the weather tool. And then that weather tool, by using the weather API, it will gives the information like what is the current weather of Mumbai. Now, whatever the information it has extracted from the weather API, it will pass that again to that LLM, and that LLM will observe the output from that particular tool. And if it has seen that it has provided the current weather of the Mumbai, it will not loop it again. It will directly provide the output to the user. So I think you have got the gist of the ReAct agent. How does it work? So let's directly jump into the implementation part. So for the implementation part, we are going to create a basic ReAct agent which will be having an access to Wikipedia tool. So we will see in the implementation, the basic function of this ReAct agent will be if a user asks a query, the ReAct agent will first analyze the user's query and it will see if it needs to call the Wikipedia tool or not. And if it sees like it needs to call the Wikipedia tool, it will pass some information to the Wikipedia tool. Like user is asking for this information, it will fetch that information from the Wikipedia tool, observe it again and see if it has the answer for the user's query, and if it has the user's query's answer, it will extract that answer and provide it to the user. And if it does not have answer to the user's query, it will rerun that loop again, as we have seen how this ReAct agent works. So let's first see what are all the steps that we are going to implement in this particular code. So the first step will be, we will be installing all the required libraries. Then we will instantiate our LLM. We will be using the GPT. Then we will initialize the LangSmith to trace all the steps that this graph will follow. Then we will create the state for the graph. This state will pass on to all the nodes and edges of the graph. Then we will initialize our tool, that Wikipedia tool. And then finally we will create our graph, compile it, and then execute that graph. And we will see how does it work. Finally, in the last step, we'll be also using a pre-built component from the LangGraph, which is more simpler and easy to implement. The only difference is when we are creating the graph from the basic feature from the LangGraph, we will be having more control over our graph. But with the pre-built component, we don't have that much control over our graph. So now we have seen all the steps that we are going to implement. So let's jump into the first step. Firstly, let's see all the libraries that we require. The first one is LangGraph. We are going to create our ReAct agent using this LangGraph library. The second one is LangChain OpenAI. We are going to utilize OpenAI GPT for our LLM. The third one is Wikipedia. We are going to utilize this Wikipedia library in our Wikipedia tool. So if you haven't already installed these libraries, uncomment these lines and install these libraries first. As I have already installed these libraries, I need not to install it again. Now let's instantiate our LLM. So over here you can see I have used Chat OpenAI from LangChain OpenAI and passed GPT 4.1 nano model over here. So we are going to utilize this GPT 4.1 nano model in this particular notebook. But you need not to use this particular model. You can use any other model as per your convenience. Like you can use Anthropic, Gemini or any other open source model. But if you are using GPT 4.1 nano model, you need to pass OpenAI API key. And for that, you need to get your own OpenAI API from OpenAI directly. And save it in your system variable as I have done. And pass it over here in this API key parameter. As I am fetching this from my environment variable. So let's run this cell and it will instantiate our LLM. Now once it has initialized, let's pass it a simple query and let's see is it working fine or not. So you can see it has generated this hello, how can I assist you today? So we can see it is working fine. Now our LLM has been initialized. Let's initialize the LangSmith. Now, as I have already told you, we are going to utilize this LangSmith to trace all the steps that our LangGraph or the graph will follow. So for this LangSmith also, you need to have your LangSmith API key. For LangSmith API, you can go to LangSmith website and sign up for free over here. And once you sign up for free by using your Gmail directly, you can see this dashboard. And over here in this dashboard, you can go to menu and over here in settings, you can create your own API key. So over here from the plus icon, you can create your own API key. Now you can use this API key. As you can see, I have created this API key and I have already saved it in my environment variable. So I need not to pass it over here directly. It is already fetching from my environment variable. Now there are two other parameters that we need to pass. The first one is LangSmith tracing. I have passed it as true, which will make sure that it will start tracing all the steps in this notebook. And second one is the name of the project. So over here you can see ReAct agent with LangGraph. This is the project name that we are going to utilize in this notebook. So as in your LangSmith, there can be multiple projects. So you need to identify which is your current project that you are working on. For that part, you need to name your project over here also. So let's run this cell and it will initialize our LangSmith and it will start tracing. So now let's jump into the next step. So let's start building the graph by initializing few components of the graph. So let's first see which particular state we are going to utilize in this graph. As LangGraph is a stateful orchestration framework, it requires a state to be passed on to every node and every edges of the graph. So what is a state in a graph? A state is basically a shared data structure which usually depicts the current snapshot of the application. So like over here you can see we are going to use message state for this graph. So usually these chat models, as we are using this chat model, chat LLM, it requires list of messages to be passed to it such that it can keep track of the previous messages. So if we click on this message state over here, you can see this is basically a type dict and it can have list of messages. And over here you can see any messages. So what does it mean by any messages? Any messages are basically like human messages when a user is passing the message. AI messages, whatever the LLM is generating. System messages, whatever the instructions that we are providing to the LLM. And after that, you can see there is a add messages reducer function. For now, you can just understand the use of what is the use of this reducer function add messages. Like if we are going to directly use this type dict, and then we are directly using this list for the messages. Whenever it will be passed to the next node, it will just overwrite it. But as we want to pass the list of messages to the LLM such that it can have the information from the previous queries, we need to use this reducer function such that it can keep on adding the next messages whichever it is getting. That can be AI message or tool message or human message. So this is basically the message state that we are going to utilize. So let's run these cells and let's see an example how this message state works. So let's say I have created this human message and I have passed this content, who won the ODI Cricket World Cup 2011, and I have given it a name, and this is a optional name which can be identifier for this particular human message. So let's run this cell. You can see this has created a human message and it has no additional quarks and responsibility data for now. But you can see there is a name mentioned over here which we have provided here. Now let's print it, and you can see there is a name mentioned and who won the ODI Cricket World Cup 2011. Now let's create that message state, and in the message, as we have already seen, message state, the messages is the key, and we can pass that human message as a list to this messages. As you can see, it is a list of any messages. So I have passed this and it will create this message state. Now let's pass that state to this LLM and see for the result, whatever the result this LLM will provide. Now you can see it has provided India won the ICC Cricket World Cup 2011. Now what we will do, we will append this result from this LLM such that that state is having both the information. So over here I have appended this, and you can see it is having now two messages. The first one is who won the ODI Cricket World Cup 2011, and second one is India won the ICC World Cup 2011. Now if I want to again ask a new question such that you can see over here, I have asked like which team did India beat in finals. I haven't provided any context like which particular tournament, which particular year. I have just asked it like which team did India beat in the finals, and I have appended that message to that particular state directly. So let's run this cell, and when I print these messages, you can see it has all those three messages over here, like who won the ODI Cricket World Cup, India won the ICC World Cup, and then which team did India beat in the finals. All three messages in it. Now when I pass this state to this LLM, it will be having all the information with it, and you can see it is clearly able to respond like India defeated Sri Lanka in the final of the 2011 World Cup. And you can see we haven't provided it any other context in the recent messages. In this way, when we create this state and when we are using this message state with a reducer function, we can have the previous information from the previous queries and we can directly pass it to the LLM. And one more thing is, like as we have seen in that message state class, it is a type dict, but we can either choose a type dict or a pydantic model. You can utilize these type dict or a pydantic model as per your need. So now let's jump into the next component of the graph. So let's see the tool that we are going to utilize in this graph. As I have already told you, we are going to utilize this Wikipedia tool. So for that, we need to initialize this Wikipedia, and we are going to utilize these two classes over here. The first one is Wikipedia Query Run. Second one is Wikipedia API Wrapper. Wikipedia Query Run is a tool that we are going to use for the Wikipedia basically API, and Wikipedia API Wrapper is a wrapper around that API which is going to search in the Wikipedia as you pass the query to it. So let's initialize this Wikipedia. And over here you can see I have passed this top K results as 1, which will make sure that it only gives us a single response from the Wikipedia such that we can get the fast results. Now let's see an example, and over here you can see I have passed a simple query to Wikipedia like FIFA World Cup 2026. So let's run this cell and it will search in the Wikipedia and provide us the result. You can see it has provided us a single result, and it has provided the page named as 2026 FIFA World Cup and summary of it over here. Now for our graph, we are going to create a function which will work as a tool for the graph and search in the Wikipedia. This tool will basically require a query. That query will be related to the user's input query. So like let's say user asks like tell me about 2026 FIFA World Cup. LLM will try to generate a query for the Wikipedia, as we have seen like this, like 2026 FIFA World Cup, and it will pass that query to this particular function, or you can say tool, and then this will run that particular query through this Wikipedia API and provide us the result. So let's run this cell and it will create our tool. Now we have this search Wikipedia tool, but to make sure that LLM has the knowledge of this Wikipedia tool, we need to bind this tool with this LLM. So we are having that GPT 4.1 nano model. We need to bind this particular tool to this LLM. So we can directly use this bind tools function with this LLM and pass the list of tools that we are going to use. As you can see, we are only using a single tool over here. So we can pass that inside a list and it will bind that particular Wikipedia to this particular LLM. So let's run this cell and it will create our LLM with tools. So now we have binded the LLM with the tool, and we have the tool, that Wikipedia tool, and we have the state. So let's work on the final step of the graph by defining the flow of the graph. Let's first define a node. This node is basically will be required to call the LLM with the provided message state. So let's run this cell, and over here in this particular call LLM function, you can see it takes the message state, invoke the LLM, and return the message response. So this will basically update that message state by adding the response that it gets from the LLM. Now over here you can see in the first line I have imported two modules, the tool node and the tools condition. This tool node module is a node that is a wrapper around our tool, that search Wikipedia tool, and it will basically run the that particular tool, that Wikipedia tool, based on the last message provided by the LLM. So let's say LLM has provided a message like it needs to call the search Wikipedia tool. This tool node will make sure that search Wikipedia is getting called by fetching the information from the last AI message. And the second message is tools condition. This is basically a function which only returns either of two literals. Either it is a tools or it is a end. So what it does is like if it returns the tools, it will basically call the tool a node, and if it returns the end, it will basically end the graph. So over here you can see I have used it from the LangGraph prebuilt module because if we do not use these prebuilt modules, we might need to write it ourselves. So like we need to write a wrapper around that search Wikipedia tool, and then we might also need to write this function tools condition. Now let's import a state graph, which is basically initialize our graph, and this start is a predefined node in the graph by LangGraph, such that it makes sure that graphs start from here, and this last line is will be required to display the graph. So let's run this cell and it will initialize these modules. So now over here you can see that I have defined the graph. The first line is where I have initialized the graph with the help of state graph, and over here in its description you can clearly see that it is a graph whose nodes communicate by reading and writing to a shared state, and that shared state is messages state over here, which will be passed on to each node in this particular graph. Now in the next few lines you can see I have created two nodes. These are the two nodes, and there are two edges. The first one is this and second one is this, and there is one conditional edge also, this one. Now let's first talk about the node. So now when you are defining the node in LangGraph, you need to pass two basic things. The first one is node name, that is over here you can see call LLM, and second one is the action that it requires to take. So this call LLM name is provided to this node, which will make sure that whenever some edge is calling to this particular tool, want to call this particular call LLM tool, it will use this call LLM name, and it will basically identify this particular node. Now over here you can see we have defined two nodes. The first one is call LLM, which will make sure that whatever the message state is there, it will use that message state and call the LLM and provide the response. The second node is that Wikipedia tool node, and we have used that tool node class over here, which will make sure that based on the last AI message, it will call the tool provided to it. So over here you can see we have only provided one single tool. So if our LLM response is like it needs to call the Wikipedia tool, this particular node will make sure that it will call the tool. Now there are two edges. The first is between start and the call LLM node, so that whenever user asks a query, that query is directly passed to the call LLM node, and LLM will decide for the next step. Now there is a second edge that is between the tools, that is this particular, as we are only having a single tool, this search Wikipedia tool, and the call LLM. So what will happen here, like whatever the response we get from the that particular tool, it will be passed to the LLM, and LLM will decide to what it needs to take, what it needs to work on the next step. Now there is one conditional edge also. So this conditional edge is required based on the LLM's output. So as per the LLM's output, as we have already seen, this tools condition will either return a tools literal or and literal. So if based on the LLM's output, if this tools condition returns a tools literal, it will basically call that tool node, and if it returns and literal, it will end the graph. Now as we have defined the graph, we can compile this graph, and this will create our ReAct graph. So let's display this graph, and we can see it more clearly with the help of this with this image. So over here you can see there is start node, there is call LLM node, and there is a tool node, and there is an end. So you can see there are dotted lines over here and solid lines over here. Whenever you see a dotted line in a LangGraph, it means that there is a conditional edge. So when user asks a query from the start, it will pass on to the LLM. LLM will reason about it and see if it needs to call the tool, or it can provide the answer and actually end the graph. If LLM thinks it needs to call the tool, it will call that tool. In our case, it is only having that Wikipedia tool, so it will call the Wikipedia tool, and Wikipedia tool will return the some result. Those results will be passed on to the LLM, and that LLM will again reason it out and think what it needs to do next. If it sees that the response from the Wikipedia has the answer to the user's query, it will end the graph. And if it does not think that it has the answer, it will again call the tool with some different query. So this is the graph that we have created. Now let's run it with some simple queries. So over here you can see that I have created a simple message. Where will the FIFA World Cup 2026 be held? So after that, let's run this graph. Running this graph is very simple. We can either invoke this graph or we can stream this graph. So like invoking will return the result at once, but a stream will make sure that it streams out the tokens that are returned by the LLM. So let's run this cell and let's see the output from the LLM. So now over here you can see LLM has provided the result. Now we can see the flow from the graph. So this is the input that we have given to this ReAct agent. Where will the FIFA World Cup 2026 be held? And you can see that the response from the AI message. It has provided that it needs to call the search Wikipedia. There is a mention of tool calls, and it needs to call the search Wikipedia, and the argument which it will pass to the search Wikipedia is FIFA World Cup 2026. And we have seen earlier, this particular argument will be passed to the search Wikipedia as a query. This query will be passed to this Wikipedia and it will fetch the result. Now this is generated by the LLM. Now as we have this tool node and we have this conditional edge, it will return this particular tool. It will basically return that tools from the tool condition, from this particular tools condition function, and it will call that particular tool. Now over here you can see that tool has been called, this search Wikipedia tool, and it has provided this result, this particular result. this result was passed to that particular LLM, and it again sees that what it needs to do next. And then you can see that it has find out the answer and it has provided that answer to the user. You can see over here the FIFA World Cup 2026 will be jointly hosted by 3 North American countries: US, Canada and Mexico. So this is the whole flow that you can see directly from the graph output. Now if you just want the final output from the LLM, you can directly fetch the last response from the messages list and you can fetch the content from it. Now this is the basic ReAct agent that we have created from this LangGraph. Now we can also see all these traces using LangSmith. So let's go to LangSmith website, and over here you can see there is a project named ReAct agent with LangGraph has been created, and under this you can see bunch of traces that has been done as we call the LLM multiple times. And we can see the recent one, this LangGraph one, and in this LangGraph one we can see all the traces and all the steps that this LangGraph has followed. So let's see the first one. The first one is this call LLM. You can see over here we have provided this input. This is a human message where will the FIFA World Cup 2026 be held, and you can see the AI response is this query FIFA World Cup 2026, and it asked to search in the Wikipedia and it asked to call the tool. So this was the response from the LLM. Now this is the first one. Second one is it will call the tool. Over here you can see the input will be that search query from the LLM, and over here you can see the output from the that Wikipedia tool. Now after this it will again call the LLM, and now the input to the LLM will be that response from the Wikipedia and the previous responses also, these responses also, and like those messages also. And after that LLM output is this. It has find out the final answer that FIFA World Cup 2026 will be jointly held by 3 countries. So this is the whole trace back that you can see in this LangSmith, and it is very efficient that I have used it, and it can help you a lot while tracing and debugging your code. So now let's implement the last part of this video. We will be using LangGraph's prebuilt library to create this ReAct agent. So it is quite straightforward. We can utilize this create ReAct agent module from this LangGraph prebuilt library. So let's run this cell, and you can see over here we can instantiate this create ReAct agent just by passing the LLM, the model, and the tools which are required. So in our case we only need to pass the search Wikipedia tool. Let's run this cell and it will instantiate this agent. Now let's display the graph, and we can see over here it has created exactly the same ReAct agent graph that we have created earlier with the basic features from the LangGraph that we have seen. Only the difference is like the name of the nodes are different now, as I have used that call LLM node, and in this pre-built library it has used this agent node. So our graph is created. Let's run this ReAct agent and just passing the same message like where will be the 2026 FIFA World Cup will be held. Let's print the message that it has provided. You can see it has run the similar steps, and like firstly calling the Wikipedia tool, fetching the results from the Wikipedia tool, and providing the final response from it. And you can see final response from it over here. Like it has provided that the 2026 FIFA World Cup will be held by 3 countries. So yeah, it is quite straightforward. So whenever you are in a hurry, you want to test your logic, you can directly use this create ReAct agent from this LangGraph pre-built library. But when you want to make it production ready, I would suggest to use LangGraph's basic features like nodes, edges, and state, so that you will be having more control over your code and over your agent, and you can modify it later. So yeah, that's it. We have built a ReAct agent using this LangGraph. In future videos, we will be implementing more awesome features from the LangGraph. So thanks for making till the end of this video. Goodbye until the next time.